Guys, welcome back to lesson 110. And so after today, we have 10 more lessons. Today's lesson is going to be important for life in general. It's not something that we will see often in math per se, but you need to know how to find interest. And so we're actually going to talk about simple and compound interest. Compound interest is harder than simple. Simple is really easy. That's why it's called simple. It's just finding a percentage of an amount of money and then adding that percentage all the time to the same amount of money. And so it's pretty easy, all right? And I'm going to go over a little bit of examples. Before I go into example 1 and 2, I think this lesson has how many examples? 1, 2, 3, 4. It has 4 examples. So before I go into the different examples, we're going to do that. Now, example 2 says to use a calculator. For the most part, you don't have to use a calculator for our problems. The reason you have to use a calculator for the problem in example 2 is because it's a lot of years. And so you will see what happens if we ask for you to give us compound interest after a certain amount of time. It becomes super hard to do. So it's just easier to do it that way. But other than that, let's just jump into the lesson and see the difference between simple and compound interest. All right, so we are talking about simple and compound interest. So the first thing is that you have to get a little bit familiar with the terms we're going to use. The first term we're going to use is principal. Principal means the amount you start with, okay? So the principal means the money, the amount of money you start with. There's 2 ways that we're going to use this in the real world. First is the money that you start with, that you have. Or second, which is a way more common scenario in real life, is the money that they lent you, meaning the money that they give you. And what happens is that they will give you the money, but they will charge you interest on the money that they let you borrow. So if they let you borrow $100, later on they don't only want the $100, they want $100 plus the interest that gave you. And so simple is way better always than compound for several reasons. And so the second thing that we need to know is the percent rate or the rate. The rate is 6% for both simple and compound, because I'm going to compare and contrast in this example, in this scenario, so that we can actually know what it is and later on get really into the lesson. And the third thing is the term. We need to know what the terms are, right? The term means the amount of time. So after 3 years, how much would it be? So we're going to do simple interest for $100 at 6% for 3 years, okay? So this is pretty easy. First of all, can you do math with percentages? Absolutely not. You have to change it into a decimal. So when you change it into a decimal, it's going to be 0.06. Be careful about that, right? And so how do you do the math? Well, you get $100 and you multiply by 6%, 0.06, and 6 times 0 is 0, 6 times 0 is 0, 6 times 1 is 6. Then placeholder, 1, 2, 3, 2 placeholders, 1, 2, 3. Then you add it all together, 0, 0, 6, 0, 0. Right? How many decimal points? Well, I only have 2 decimal points, so it would be $6. Yay! So that's the interest, all right? That's all I found. I found the interest. So what do we have to do? After the first year, obviously first year, we're going to have $6 plus the $100 that you have. So $106. Please understand something, and this is super important. What we did with interest, and what we're always going to be doing, is 2 mathematical operations. 2 things that you should know how to do. Hopefully everybody knows how to multiply and add. Okay? Multiply and add. That's all you need to do. However, what I'm going to tell you is that sometimes you can switch the order, but you have to be careful when you switch the order, because if you switch the order, you have to switch the way you do it as well. But understand something. To get $106, I did what? I multiplied my principal, the amount I had at first, by the percentage, right? Not in the percentage, because we cannot do math with percent, in decimal form. Once we did that, we got $6. That's fine, right? That's not hard to do. Everybody should know how to do that. But when I found the $6, then I added that to $100. And I got this. Yes? So first I multiplied and then I added. But in simple interest, it's so simple that in the second year, you're still going to get the same 6% based on the principal, on the original amount, which we know it's $6. So what is $106 plus $6? It's $112. And the third year would be $118. And that's it. That's simple interest. This is why it's so simple, because literally you just have to find once what the interest rate is and then keep adding the same number over and over and over and over again. Okay? So for simple interest, I would always say the order is first to multiply and then to add. I hope everybody understands this. It's not very hard. Now let's go to compound. All right. Note that it's compound and not difficult. Not difficult interest. But the same thing, the same principle applies. The same rule applies at first. The rule is don't do math with percentages, but with decimal, right? And multiply 100 times 6% to get the first year. So after the first year, it would be the same, okay? But if most of you are going to be like, well, if after the first year we got $6 and it's still, you know, it's still the same, then where is it different? Well, it's going to change from now on, because what happens is that for simple interest, we always add 6% of the principal of what we have at first. But for compound interest, we're going to use 6% not of the principal, but of what I have afterwards. So the first year is obviously from 100 that I get 6%. For the second year, I have to get 6% of $106, which is not going to be the same thing as $6. It's not, because 106 is not 100. And so I have to find 6% of $106. I'm going to explain this to you two ways. The easier way, the way that most students understand, and the way that I do it. And the way that I do it, it's not that it's super hard to do it, it's just it makes it easier because I'm combining two steps into one, and so I always have to just do one step. But I will explain so that you guys don't get confused. So the first thing is I'm going to do it just like that. I'm going to multiply by 6%. 6 times 6 is 36. A 6 goes down and a 3 goes up, right? 0 times 6 is 0, plus 3 is 3, 36. And 6 times 1 is 6, 636. Then we have to find all the zeros. So placeholder, 1, 2, 3. Two placeholders, 1, 2, 3, right, for the zeros. Then I add all of these together. I got 6, 3, 6, two decimal places, $6.36. You see, different. Because in the second year, I have $112 for my simple interest. But for my compound interest, I'm going to get we need to add $106 here. So we add together and we get 6. 6 and 6 is 12. $112.36. So you see how it's different already? This is why this one takes a little bit more work, but it's not like it's super difficult. What happens is that you have to do the work each and every time they ask for the year. This is why we need a calculator later on, because they're going to ask you for a long time. And what if they say 20 years? You have to keep on multiplying and adding 20 different times just to solve one answer. That is crazy. Okay? So, hopefully you understand. the difference is that now I have to find 6% not of $106, not of $100, but of $112 with 36 cents. You cannot forget the 36 cents. So we're going to do the same thing, okay? We're just going to multiply 6% by this. 6 and 6 is 36, and 3 goes up. 3 times 6 is 18, plus 3 is 21, and a 2 goes up. 2 times 6 is 12, plus 2 is 14, and a 1 goes up. 1 times 6 is 6, plus 1 is 7, and 6 times 1 is 6. So we have that at first, placeholder. Then we have 1, 2, 3, 4, 5. 2 placeholders and 5 zeros. 1, 2, 3, 4, 5. We add it all together. 6 gets here. 1, 4, 7, 6. I don't really care about the zeros, to be honest with you. How many decimal places we have here? We have 2 from the 36 and 2 from the 0.06, so we need 4 decimal places. Hold on a second. Pennies only go until the second decimal place. Yes, that's correct. So this 2, unless the 1 is going to make the 4 round up, we use it. But because in this particular scenario it didn't do anything, we just leave it like that. And now we have to add $112 with 36 cents to $6.74. 4 and 6 is 0, and a 1 goes up. 7 times 3 is 10, plus 1 is 11, and a 1 goes up. 6 plus 2 is 8, plus 1 is 9. Look at that. In this one is $118 for the third year. In this one, the third year is $111 with 10 cents. $119, not 11. I don't know why it said 11. $119 with 10 cents. That is the difference between compound and simple interest. Now, what I'm going to do is I'm going to pause right now. I'm going to erase that side. I'm going to show you how I would do it so that I don't have to add and subtract and add and subtract. But feel free to do it if you think it's easier than my method. Okay, now I'm going to show you how to do it my way. So I have compound interest, Mr. Silver's way. Again, same principle, same rate, same term. So what I'm going to do is I'm going to find 6%. Okay, 6% of 100. But before I do that, understand something. I'm always multiplying here and then adding, right? And then I multiplied here and then I add it. So I always multiply and add, multiply and add, multiply and add. What if I want to do it differently and I want to add and then multiply? Okay, but so what am I adding if I don't know how much percentage 6% of $100 is or 6% of my original amount is? Well, I can add the percentages. Okay, so that's what I'm going to do. I'm going to add the percentages first and then multiply that. Okay, and that way I don't have to be adding and multiplying and adding, multiplying and adding. I'm just going to keep on multiplying by that percent number that I get. And it's really easy because if I have $100, how much percentage do you have of the $100? You have 100% of the $100. Okay, so that's pretty easy. That would be 100%. Now, understand something. I could change the amount of money that you have at the beginning, but it would still be 100%. Like, for example, if a video game cost $60 and you paid $60 for it, how much percentage did you pay for it? 60%? No, you paid 100% of it. So that's my point. My point is that it doesn't matter how much money you have or how much money something costs. You paid 100% of it. Okay? Unless obviously it's on sale, which is the second part of this lesson, but we're not there yet. Okay? We're still here. We haven't even done the examples. I understand this is a slower class than others, but don't worry. So, We have 100% and we have 6%. What is 100 plus 6%? Well, it's 106%. Yay! So now we're going to make this into a decimal because can you do math with percentages? Absolutely not. So it's going to be 1.06. And that's what I'm going to use. I'm going to use that to find my first year. Look, I'm going to get $100 times 1.06. 6 times 0 is 0. 6 times 0 is 0. 6 times 1 is 6. Okay. 0 times placeholder. 0 times 0 is 0. 0 times 0 is 0. 0 times 1 is 0. Two placeholders. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. Okay, now I'm going to add. 0 times 0 is 0. 0 times 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 plus 0 is 0. 6 plus 0 plus 0 is 6. 0 plus 0 is 0. 1 is 1. Two decimal places, 106%. $106, I mean. That is my first year. Oh, look at that. My first years are the same. Now, what if I multiply that by, and I'm going to erase those two zeros here so that it makes it simple, by 1.06 again. Well, 6 times 6 is 36, and a 3 goes up. 0 times 6 is 30, is 0, plus 3 is 3. 6 times 1 is 6. Placeholder, 0 times 0 is 0. 0 times 6 is 0. 0 times 0 is 0. 0 times 1 is 0. Two placeholders. 1 times 6 is 6. 1 times 0 is 0. 1 times 1 is 1. 6, 3. 6 plus 6 is 12, and a 1 goes up. Wow, look at that. 112.36. I got that for my second year there. I got that for my second year there. And look at my third year. I'm going to put it right here in between the lines. It's going to be 112.36 times 1.06. 6 times 6 is 36, and a 3 goes up. 3 times 6 is 18, plus 3 is 21, and a 2 goes up. 2 times 6 is 12, plus 2 is 14, and a 1 goes up. 1 times 6 is 6, plus 1 is 7, and 6 times 1 is 6. Then we have placeholder, and then we have 1, 2, 3, 4, 5 zeros, 2 placeholders. And we have 1 times 6, 1 times 3, 1 times 2, 1 times 1, 1 times 1. Then we add 6 times 0, 0 is 6. 1 plus 0 is 1. 4 plus 6 is 0, and a 1 goes up. 7 plus 3 is 10, plus 1 is 11, and a 1 goes up. 6 plus 1 is 7, plus 2 is 9. 1, 1. So I end up with, I'm going to move this number down here, which is 1191016. How many decimal places? I have 4 decimal places. 1, 2, 3, 4. Isn't this what I got for the third one? $119 with 10 cents. So that is another way of doing it. I rather do it my way, but if you do it that way, it's okay. You do it the way it's easier for you. Now we can actually jump into the lesson and look at the examples, okay? So let's do that. Okay, so if you look at your book in example 1, they tell you, we have $1,000 and it's going to be compounded 10%. It's going to be compound interest, right? Compound interest for 10%, and it's going to be for 5 years, and you have to do a table for each one. So what I'm telling you is they don't really care how you do it as long as you do it. And they don't really even show you how to do it. They literally just give you the table, like if it was magic. And it's not like that. That's not how it works. And so the first thing that you have to do is find 10%. 10% is going to be 0.1, right? Because you can never do math with percentages. I've been saying this over and over and over again in this lesson. And I say it all the time anyway during class time. Let me clean the board because it's kind of dirty. It's getting to me. It's just, this board is a little bit different than the ones we have at school. I like the ones at school better. Anyway, but we work with what we have and we are thankful for it. So, then what we have here is we're going to have 10% is 0.1, right? But what I'm going to do is I'm going to add the percentages first. $1,000 is how much percentage? $1,000 is 100%. And 10% plus 100% is 110%. 110% as a decimal is going to be 1.1. So my first year would be $1,000 times 1.1. I'm doing it my method. You could do it the other way, but I'm going to do it this way because it's going to be a lot quicker for this example because I have to do it 5 years, okay? For example 2, we're going to use a calculator. In fact, I might not even go over example 2 just because they tell you how to use a calculator. I'm just going to tell you that I'm going to just write on the board what you have to write in the calculator to be able to find what you do. And it's not that hard. Example 3. It's easier, and that one will do. But for this one and for example 3, I'm going to do it on the board. For example 2, I'm just going to write what you have to put in your calculator for work. But don't worry, as I told you, in your homework and in your test, especially in your test, I will never give you really hard compound interest, and I'm not going to ask you for more than maybe 3 years. So it's not like you have to do all the work that I'm going to do for this particular problem. You don't have to do it for your test. So 1 times 0 is 0, 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1. Placeholder. 1 times 0 is 0, 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1. We add them together. 0 and 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1. And so we add them all together. How many decimal places? Just 1. So we get, after the first year, we get $1,100. Then I'm going to multiply that again by 1.1. Okay, again, you don't have to do what I do, but to me, it's easier. And for this particular example, it's going to make it easier for me to go over the 5 years quicker. So 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1. Placeholder. 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1. We add them together. 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 is 2, and 1 is 1. How many decimal places? Just 1. So it'd be $1,210. Second year. Third year times 1.1. So 1 times 0 is 0, 1 times 1 is 1, 1 times 2 is 2, 1 times 1 is 1. Yes? Placeholder. 1 times 0 is 0, 1 times 1 is 1, 1 times 2 is 2, 1 times 1 is 1. 0, 1, 3, 3, 1. So in here, decimal place is 1. $1,331 for 3 years. Okay, so I have 3 years. Now I have to move on to 4 and 5. Year 4 is going to be 1,331 times 1.1. Just messed up the board that I just cleaned. It's okay. 1 times 1 is 1. 1 times 3 is 3. 1 times 3 is 3. 1 times 1 is 1. I'm sorry. This board, like, when you erase it, it makes the little dust from the expo marker. And it's just, oh, It gets into my throat. It's so uncomfortable. 1 times 3. Okay, so where was it? I'm obviously doing math. Duh. 1 times 1 is 1. 1 times 3 is 3. 1 times 3 is 3. 1 times 1 is 1. Okay, yeah. So placeholder. That's where I was in the placeholder. 1 times 1 is 1. 1 times 3 is 3. 1 times 3 is 3. 1 times 1 is 1. I add them together. 1, 4, 6, 4, 1. Decimal place, 1 decimal place. This one does matter because it's $1,464 with 10 cents. That's fourth year. Yay. Almost done. Almost done. And then 1.1. Okay. 1 times 0 is 0. 1 times 1 is 1. 1 times 4 is 4. 1 times 6 is 6. 1 times 4 is 4. 1 times 1 is 1. Placeholder. 1 times 0 is 0. 1 times 1 is 1. 1 times 4 is 4. 1 times 6 is 6. 1 times 4 is 4. 1 times 1 is 1. And I add together. 0 and 0. 1 and 0. 1. 4 and 1 plus 1 is 5. 6 plus 4 is 10. And a 1 goes up. 4 plus 6 is 10. But a 1 is 11. And a 1 goes up. 1 plus 4 is 5. Plus 1 is 6. And 1. How many decimal places? I have 3 decimal places because of the 10 and the 1. Awful 5. Awful. Just awful. After the 5th year, I'm going to get $1,610 with 51 cents. Now, if you look at your table, you can look at what I just did and compare it to the table in the book. I have the book right here. It says that the first year, we got $1,100. I said $1,100 after the first year. The second year, they put $1,210. The second year, $1,210. After the third year, they had got $1,331. After the third year, I got $1,331. After the fourth year, they got $1,464 with 10 cents. After the fourth year, $1,464 with 10 cents. In the final year, $1,610 with 51 cents. I got $1,610 with 51 cents. And that's how you do compound interest. Now let's actually look really quickly because I'm not going to go and do it because, as I said, if they ask me for 12 years, I just can't keep going on and on and on and on. But they say use a calculator to find the value of a 12 years of $2,000 investment. So you have a $2,000 investment. Okay, $2,000 investment after 12 years at 7.5%. This 7.5 would be not 7.5. It's not it. It's 0.075. But because I would actually recommend you do it my way, do 1.07, and that would be 107.5%. 1.075. And so what you have to do is you get a calculator. I know that yours might not look like mine here. You get a calculator, you put $2,000, you multiply that by 1.075, and that would be first year. And so you have to do it 12 times. That times 1.075. 2 years times 1.075. 3 years times 1.075. 4 years, and so forth. And you keep going and going and going and going until you do it 12 times. You multiply this number first by this, and then you get that answer, multiply that by that, and then you get that answer, multiply that by that, and you get another answer, multiply that by that, and then another answer. So you have to multiply by this number 12 times. The first one being $2,000 by this number. Once you do that, you're going to get it. So, because I know how to use another way of doing it, Is it this one? Uh-huh. That's exactly how you do it. Oh, do I really have to do it 12? Let's do it 12 times. Okay, I'm going to do it with you. If you're doing it, awesome for you. 0.775 once. Twice. Thrice. 4 times. 5 times. 6 times. 7 times. 8 times. 9 times. 10 times, I think. 11 times. 12 times. Okay. So after my 12th time, I got $4,763 with 55 cents, but I got 559198. I want to show you this in the calculator so that you understand what I'm talking about here. So I know that in here you might not be able to look, but whoop, boom, the magic of zooming in. 4,000, as you can see, it's $4,763, 559198. The 9 would make the 5 round up, and so it'd be $4,763 with 56 cents. And that's how your book got that answer. All right, let's move on to example number 3. Okay, so example number 3 says if we have $8,000 that we deposited into an account that gives us 6% interest, 6% interest in 1 year. After 9 months, how much do we have? So that is very important. In here, what we need to understand is the year and the interest. So if it's 6% in 1 year, in 9 months, are we going to get 6%? We're not going to get 6%. We're going to get some part of it, but not all of it. So how do we do this? We have to find what 9 months in a year are. That's pretty simple because there's 12 months in a year, right? Hopefully you guys understand that. So 9 divided by 12, right? So 9 months out of 12 months. 9 months out of 12 months would be what? Because both of them can be divided by 3, we're going to get 3/4. So 9 months is 3/4 of a year. So now what we have to do is we have to find 3/4 of the money that we have. But, and I'm not just saying that because I'm talking about a rear end. I'm just saying what you have to be careful about is what we're going to do is we're going to do interest like we've done before, right? So we're going to get $8,000 times, and I'm going to do it my way, 1.06. Sorry, I might have hit the mic. I don't know. 8,000 by 1.06, right? And so we're going to do math. Wow, doing math in a math video. Crazy. 0 times 6 is 6. 0 times 6 is, I don't know where that math came from. That's not the right math. 0 times 6 is 0. 0 times 6 is 0. 0 times 6 is 0. 0 times 6 is 48. Yay. And then placeholder, 1, 2, 3, 4. 2 placeholders, and then 1, 2, 3, and 8. Bam. And we add all together. 0, 0, 0, 8, 4, 8. How many decimals? 2 decimal places. So in 1 year, I would have gotten $480. Right? We could have just done it the other way too. Okay, so after 1 year, I would have in my account, in my bank account, I would have $8,000 from the beginning, and $480, that's what I earned. But what we need to know is in 9 months, how much am I going to have? Am I going to get $8,480? No, you're not going to get that. You're going to get part of the $480. But how much part of it? you're going to get 3/4 of it because that's what 9/10 is. So you have to multiply that by 3/4. And if we do a little proportion, which is going to be what we're going to be doing for the other two examples, proportions for consecutive discounts, that's what it's called. What we're going to do is divide or simplify this, because 48 divided by 4 is 12. And in here, 480 divided by 4 is 120. And in here it's going to be a 1. 120 times 3 or 3 times 12 is 36. And then you add the 0. So what you're going to get is $360 for 9 months that your money is in the bank account. And that's how you do example number 3. Let's move on to discounts, which is something that people get excited about, because if you want to buy things, you usually want to buy them at a discount. It's just smart. It's a smart thing to do. All right. So I thought there were 2 more examples, and I got really happy when I just saw it was 1 more. Yay! Because it's taken me a little bit to do this video. So, you know, hooray for me. Anyway, so we have an appliance store, all right? An appliance store that wants to sell a washing machine that it was originally $400. And so what they said is like, well, this is an old model. Let's actually put it on sale because we need to kind of get rid of it. And they're not just going to give you stuff for free. That's not how the world works. And so what they do is they say, okay, let's actually do that. So to do this, you have to do a little table. Yay, percentage and money. And this is where I told you that the proportions are going to come into play. So if we have $400 at first, that would be 100% of the price. But then a lot of you would be like, oh, that's easy. We put $25 here. No, 25%, not dollars. 25% here. No, wait. Time out. If they take 25% off the original price, are you paying 25% or are you paying the rest of that percent? So what I'm talking about is when they take off 25% of the $100, you're not paying 25% of it. You're paying the rest of the percentage that is left. And that would be 100 minus 25. I hope that everybody knows that it would be 75%. Yes? That is the way that you have to think about this, because every time, and I'm gonna be honest with you, when I go shopping to a store and they always have 30% off or 50% off or 40% off or whatever percent off, I never really care about the percent that they take off. I care about the percent that is remaining, because that's what I'm gonna pay. I'm not gonna pay whatever they take off. I'm gonna pay the rest of it. So what I always do when I go to a store, let's say it's 30% off and the shirt is, let's say $28 original price, and it's at 30% off. I don't think 38% of 20, or actually, let's even do it simpler. Let's say it's $30 of a shirt. And this is what I do when I go shopping. And they say it's 30% off. I know I'm not going to pay 30% off. I'm going to pay 70%. I literally do this. I multiply 3 times 7. I know 3 times 7 is $21. This is how much I'm going to pay for the shirt. I do mental math like that all the time. And I know, wow, that's a pretty good deal because it's $9 off of the price. And that's how I go shopping. And that's how I know whether or not I'm getting a good deal and how much of a good deal it is. And so that's something that I always do. This is how math actually works in the real world. And I don't understand how people are like, when am I going to use this? When you go shopping. So that's why I put $75 off, because the 25% off, it's nice to know that they took some percentage off, but that's not what you pay. You pay 75%. So we don't know what this is. So then we have to do our good old friend cross multiplication. 175 equals 400 over x. 100 over x is 100 times x equals 400 times 75. Then we're going to divide both sides by 100 first. And you know why. Right? I don't care about this. So the zeros cancel out. And so x would be 4 times 75. 5 and 4 is 20, and a 2 goes up. 7 times 4 is 14 plus 2. What? Sorry. Rewind. 5 times 4 is 20, and a 2 goes up. 4 times 7 is 28, plus 2 is 30. So the sales price is $300. But that's not it. Because what happens is that when they put it for $300, people still didn't want to buy it. And so they say, all right, let's put it 20% off the sales price, all right, of the sale price. And so the sale price was, percentage-wise, was still $100 because it's $300 now, how much it cost. It did go down. But because it's 20% off, we only care about 80%. We don't know what this is, the x, so we have to again do cross multiplication. $100 in x is going to be 100x times 300 times 80. Again, I divide by 100 on both sides. 3 times 8 is 24. The final price is $240 because that's what it's going to be. 3 times 80 is $240. That would be how you find consecutive discounts. Consecutive discounts is just super easy because it is about setting up the tables and doing cross multiplication, which is something that I've been telling you for a long time. Most of your math nowadays is just going to be a lot of setting up tables and proportions, which are solved by cross multiplication. So if you know how to do proportions, you're going to do well in this math. All right, this is it for lesson 120. Only 10 more lessons to go. Let's go!